In this video, we're going to be looking at sinusoidal functions and how we can transform them. So, in previous videos, we have looked at how we could transform the quadratic function, and we did have that formula. I believe it was a x minus, what was it? I think it was a times kx minus, I forget what it was. I'll just write d for now, plus c, where a was the vertical compression or stretch, k was the horizontal one, d was the horizontal shift in the x direction, so this way or that way, and c was the vertical up or down. So when it comes to sinusoidal functions, and we have, say, the two graphs, we have our main ones. Let's start with the basics. Y equals sine x and y equals cos x. So let's actually draw this one out. The y equals sine x. So we have let's say this is 0, and that is our y, this is our x-axis. Let's say this is 1, and this is negative 1 on our y. When we have y equals sine x, this is basically going to go in increments, or a full period is going to be 180 degrees. So our x-axis is actually going to be written in 180. Oh, sorry. My mistake. It's actually a full revolution, because I have to look at it in the form of a circle. So imagine this angle here, when it goes, if this was to go all around like a clock, counterclockwise, when you were to graph this out, you would start here and then make your way that way and come back around. So if you were to move this, you would basically have something like this, where you start here, and as you're moving in that direction, and you're going counterclockwise, so from 0 to 360, and this is 180, so you're going to go, and then this is, say, 90. From 0 to 90, you go up to the max, and then from 90 to 180, you come back down to where you were, and then from 180 to 270, you go to the lowest point, and then you come back to the main point. So let's draw that out. 360 degrees. Let's say that's 180, and that's into 4 points. So let's just pretend that's symmetrical. And there you have it. That is our sine graph. And our cos graph is very similar, actually. But our cos graph does not start at 0, because cos of at 0 is going to be actually 1. So we'll still have our 360. But So if you were to draw these together, it could be something like this. So this is cos x, and this is sin x. So really these two are really just a shift of 90 degrees from each other. So now we're going to bring this in, this formula, and we're going to apply it here, because when we think about transformation of these functions, it's the same as these ones, or very close actually. So we're going to have f of x is equal to a sine k x minus t plus c. And then for our cos, which is the same, we're going to have f of x equals a cos k x minus d plus c. So let's actually look at one example. Let's write that formula out first. F of x is equal to a sine k x minus d plus c. And now I'm going to write out our example. F of x is equal to 3 sine 2x minus 60 degrees plus 4. So let's start off with our y. So let's do x. And we're only going to draw one period here. So let's say this is 360. I'm going to say this is 1, 2, 3, 4. 1, 2, 3, 4. And you may see why. So remember, well, that might be a little long, so let's do, say 360 is somewhere here, and that's say this is 90, 180, that's 90 to 70. As we know, the sine goes from 0 to 90 through 180, and then comes up to here, and then repeats itself, but we're not going to ignore that. So I'm going to say that this color is y equals, or f of x is equal to sine x. And now let's go with a different color with our first transformation. So let's do the let's do this one now. F of x equal to sine 2x. And what that basically is a horizontal compression. If we have 2 here, that means we're compressing it in half. So now, instead of doing the full period into 360, we're going to do it into whatever this is, it's the opposite sign for it. So now wherever these points are, we're going to move it 60 over. So now instead of at 90, like if I was to split this into 3, because we have, say, 30, 60, 90, 120, 150, 180, and then we also have 210, 240, 270. That means now if we move it over 60, now we have our starting point here at 60. From 45 we're going to move it, or this point here, 60 plus 90 is now going to be 150. So that's should be something like that. And then our point ended at 180. Now it's going to end at 240. And that is that. So we actually have 2 more things to do now. We have let's do this one next, our number 3 here. Let's see if I can get a different one. This one is going to be with the 3, and that's basically a vertical stretch of 3. So exact same graph, except now the peaks or the amplitudes are going to be multiplied by 3. So now we have say 2 and 3. So now this is going to get stretched out. So the peak is now going to be here. So just like that, you can see this orange one got stretched by a factor of 3. Now the next one is even simpler. I may not have enough space on here to do it, but we'll try. This is the full one. I won't even write it again. It's just plus 4. All we're doing is moving this up by 4. So if this is at 3, we're going to need 4, 5, 6, 7. So say 7 there. That's the point. This point from 0 is now going to be here. This point is going to go up to here. This point is at -3, it's going to go here. And then back up to here at 4. And that is our new sine graph. It's a little choppy because I'm not really good freehand. But yeah, I hope that was a little helpful, even a little bit. But yeah, that's the gist of it. When it comes to transforming sine, even cosine graphs, you just start with this one instead of this one, the green one. And yeah, you should be able to do the transformations on your own. Just remember the rules from the parabolas and the quadratic functions,